We have next question, which is based out of Fourier series. This topic is dangerous for some students, but for our students it's very easy because we have studied conceptually, by tricks, by every methods, right? So now the question is, a periodic function f of x with period 2 is defined as f of x that is equal to minus 1 minus x when x is ranging from minus 1 to 0, and this function is 1 minus x when x is ranging from 0 to 1. The Fourier series of this function contains dash. What do you think? What it contains? Check it out. First of all, we have to check whether this function is even or odd. Once we understand even or odd, then we can comment on the options. So how to check whether it is even or odd? Everyone in the comment section. How to check? Sir, mathematically speaking, if f of x is equal to f of minus x, the function is even. If f of x is equal to minus of f of minus x, then the function is odd. So let us find f of minus x then, Sarji. Okay, f of x was given. Let me write that, then we can comment on f of minus x. So f of x is given as minus 1 minus x when x is ranging from minus 1 to 0. Then it is 1 minus x when x is ranging from 0 to 1. Now if I replace x with minus x, the problem here is every term is getting replaced. See, this would be minus x is now changed as, if I replace this x as minus x, this minus gets multiplied, it becomes plus x, right? Then here also minus 1 less than equal to minus x less than equal to 0. Here if I replace x with minus x, the function would look like 1 plus x, and then its range is 0 less than equal to minus x less than equal to 1. Okay, if I don't place here less than equal to, it would look more authentic because less than equal to 0 has happened here, so equal to 0 should not be here mathematically speaking. Now you guys are like, sir, I'm not getting any hint between f of x and f of minus x, whether they are equal or they are like negation of each other. I'm not getting any hint. The reason is, check the x range. First we have to fix the x range. Okay, positive x domain you need. If I need the positive x domain, check it out. What I will do is only one step. Multiply with minus 1 on everywhere, here, everywhere. So 1 0 minus x will become positive x, but while doing that crocodile change its sign. So less than equal to becomes greater than equal to. Here also less than equal to becomes greater than equal to. Now the lower part 1 plus x, just multiply minus 1 throughout. So 0 1 not 1 minus 1 it would be. Then here it would be positive x. Crocodile will change its sign, changing its sign. I hope you got this point. If you got this point, then finally can I say, if I write it as per this format, then I can say f of minus x that is equal to, check it out, 1 plus x when the range is minus 1 less than equal to x less than 0. Check it out, x should be less than 0, x is less than 0, x should be greater than equal to minus 1, x is greater than equal to minus 1. So the formatting is right. The reason is I want to match with this format. Okay, so now finally we have this function minus 1 plus x. So what is its range? Its range is, it should be greater than 0, less than 1, like this. It should be greater than 0 but less than equal to 1. Now I guess you are getting some hint. Sir, f of x and f of minus x, they are absolutely not same, but they are negation of each other. They are negation of each other means, if I ask you guys to check f of x and minus f of minus x, you will say, sir, they are same. If you don't believe me, just multiply minus here. If you multiply minus here, this term would be multiplied with minus, this term would be multiplied with minus. So minus 1 minus x, yes, matching. And here plus 1 minus x plus 1 minus x, matching. So you can see that f of x and minus f of minus x are matching with each other. If this is the scenario, obviously our function is what? Sir, our function is an odd function. If our function is odd function, then only one term will sustain. Who is that one term? Sir, the term associated with sine, that will sustain. So here I will say that a naught, a DC component, and an, the term associated with the cos, everything would be 0. So there won't be any DC component or cos component, but there would be definitely bn existing, means there would be sine term. If there is sine term existing, then we can happily say, sir, only Bombay is correct. because only sine term should exist, that is only Bombay. But some students are like, sir, what if instead of this cos, what if it was sine? Then from B and D, which option is correct? I was like, very good doubt. Then to get that, we have to take the help of the periodic fundamental period t is equal to 2, and then we have to do some calculation to get the answer. So let us perform that operation also. As you can see here, by just this calculation, we can say that only sine term exists, and we are done. But giving you more insights, we are saying, as per the Fourier series which I have taught you in the engineering mathematics concept, my style of Fourier series is always like how telecom, electrical, IN students study, where x is dependent, t is independent. In engineering mathematics, generally they take f of x, like this question, where x is independent, f is dependent, okay. But in our signaling system, we take t as independent and x is dependent on t, right? But nevertheless, you have to either by heart in this version or in this version, and then as per the question, you have to replace the terms. For now, we are seeing as per what we have studied, x of t, that is equal to a naught plus a summation n is equal to 1 to infinity a n cos of n omega naught t plus a summation n is equal to 1 to infinity bn sine of n omega naught t. Right now, you can see as per our calculation, a naught is 0, a n is 0, so this term are gone. The term which is left is summation n is equal to 1 to infinity bn sine of n omega naught t. Sir, what is omega naught? Check it out. Omega naught is angular frequency, that is equal to 2 pi divided by fundamental time period, which was given in the question. How much it was given? 2. So our omega naught is pi. Check it out. The fundamental time period is 2. It's given. Even if it is not given, then you can see higher value minus lower value, 1 plus 1, 2. Okay, so multiple methods to get the fundamental time period. As you can see here, we got the fundamental time period as 2. We substituted here. We got omega naught as pi. Substitute that omega naught here. And finally, our Fourier series now looks like, therefore, x of t is equal to summation n is equal to 1 to infinity bn sine of n omega naught is substituted as pi. But you know, our question is in terms of f and x. So as per question, for them the dependent variable is f. So here x was the dependent variable as per our calculation. As per the question calculation, f is the dependent, and as per our calculation, t was independent, but as per the question, x was the independent. So now just do that replacement and get the answer. If you see carefully enough, then n pi as per the question, t is treated as x. So yes, this is the answer, and clearly sine of n pi x, it is present in which option? Sine of n pi x, it's there in Bombay. Therefore, sine of n pi x is absolutely correct. Understood? If understood, then this is method 1. You know, right? Shrenik sir always gives you multiple methods. This is method 1. Who do all this mathematical calculation? Yeah, I don't do all this mathematical calculation. I rather follow the tricks and techniques. Now, if you do not know how to check the even or odd graphs graphically, then method 2 is difficult for you. But if you know how to check whether a function is even or odd using graph, then it's very simple. Check it out. What was our function? So our function was f of x, that is equal to minus 1 minus x when x is ranging in this domain, and our function is 1 minus x when x is ranging in this domain. Agreed? Yes, Sarji. Now if I tell you guys, this is x-axis, this is f of x, plot. Sir, while plotting we have to be very careful because this is piecewise function. In 0 to 1 the graph is linear, working like 1 minus x. Well sir, I do not know how to plot this 1 minus x. No worries. First substitute x is 0, then the graph is looking at 1. When x is 0, graph is at 1. When x is 1, the graph is at 0. So this is the line. This is your 1 minus x. Okay, so from 0 to 1 we have this 1 minus x graph. Now from minus 1 to 0, check it out, minus 1 to 0, when I substitute x is 0, the graph is at minus 1. Okay, so clearly we can see a discontinuity at x is equal to 0. Just mathematical concepts, revising again. Nevertheless, when I substitute x is -1, what I am getting? Sir, you are getting 0. Okay, so now 2 points, one straight line can be drawn. How to check whether this is odd or even? If it was even, then it would behave as mirror. Means the right graph, if I take mirror, this y-axis represents the mirror, okay? So if I do the mirror, it would look like this. And if my graph had like this line in -1 to 0, I would have told that my function is even. But in our question, is it so? No sir, in our question we do not have this line, so the graph is not even. But now to get odd signal, it's very simple. It's a two-step. First do the mirror, then multiply with -1. So if I multiply with -1 to this graph, it will go down like this. So if you are getting this as the output after performing two steps, first mirror and then multiply -1 to the mirrored version, if you are getting this as the resultant graph, then absolutely the function is odd function, or you can say the odd signal. Simple. And you can also check that in your sine and cos graphs as well. You usually say that cos is even, sine is odd. Follow this technique, you will get the result same to same. Sir, you told just do the mirror. If it's getting mirror only, then it's even. If it is not getting mirrored, then the mirror signal multiplied with -1. If you are getting that as the resultant, then the graph is the odd graph, and it's matching to every function of even and odd. Yes? Okay, so finally we got it that by drawing the graph, this is the odd signal. And if it is the odd signal, then we can clearly say that only one term exists, or only sine term exists. Sine term exists. Okay. Therefore, the right answer is Bombay.